You know that satisfying snap when you break a KitKat? It sounds simple, but behind that sound lies one of the most complex, perfectly timed manufacturing dances on Earth. Every second, hundreds of bars are born, tested, rejected, crushed, reborn, and wrapped before you even finish unwrapping one. And the wildest part? The chocolate inside your KitKat might have lived another life before it ever reached your hands. This is Process Crate, and today we're stepping inside a secret world of melted cocoa, robotic precision, and one surprisingly dark twist, the candy that eats itself. Our story doesn't start with shiny red wrappers or supermarket shelves. It begins thousands of miles away beneath the heavy, humid air of West Africa's Ivory Coast, the beating heart of the global cocoa trade. Out here, the scent of the earth mixes with smoke from wood fires and the sweetness of ripe cocoa pods hanging low from trees. Farmers walk barefoot between rows of green, machetes in hand, slicing through thick husks to reveal the treasure inside. Pale, sticky beans that look nothing like chocolate, yet hold all its promise. Each pod is split open by hand, each bean scooped out and piled onto woven mats where they're left to ferment beneath banana leaves. Days later, they're spread out in the sun to dry, on a process as old as chocolate itself. The sound of beans rustling in the wind echoes across entire villages. These same beans, now hardened and fragrant, are packed into burlap sacks, stenciled with shipping codes and factory destinations. Trucks carry them down long dirt roads, past palm groves and fishing towns, to the ports where freighters wait. Thousands of tons of raw cocoa are loaded aboard ships bound for Europe and beyond. Every sack carries more than just an ingredient. It carries the beginning of every KitKat bar you've ever tasted. The first chapter of a story that started under a scorching sun, written by hands that may never see the final product, but without which the world's most famous chocolate bar wouldn't exist at all. When those burlap sacks finally reach the chocolate plant, the atmosphere changes completely. The quiet rhythm of the farms is replaced by a constant mechanical heartbeat, the sound of an industry running 24 hours a day. Conveyor belts rattle and hum like a living organism, while massive hoppers roar as they swallow mountains of cocoa beans. The air is thick with warmth and the faint bitterness of roasting chocolate. It's not just a smell, it's a signal that the transformation is about to begin. Workers in hairnets and uniforms guide the incoming loads toward towering metal funnels that stretch up several stories high. This is where chaos becomes order. The first phase is purification, a storm of movement inside stainless steel sifters that shake with such force the floor seems to vibrate. The beans tumble through layers of mesh, while jets of air blast away anything that doesn't belong. Bits of wood, tiny stones, even stray fibers from the sacks themselves. Every unwanted fragment is separated and sucked into waste chutes, leaving behind nothing but pure, untainted cocoa. From there, the clean beans move into the crushers. This is the moment the factory begins to smell like chocolate for real. Inside the grinding chambers, steel rollers crack open each bean with a rhythmic crunch, splitting them into two distinct parts, the outer husk and the rich brown core known as the nib. The sound is hypnotic, like gravel tumbling in a drum. Then, a rush of air pulls the brittle shells upward through vacuum pipes, leaving the heavier nibs to fall down onto the next conveyor. Those tiny, dark fragments don't look like much, but they hold the soul of every chocolate bar ever made. Dense, with natural fats, packed with flavor, they're the foundation of what will soon become that familiar, melt-on-your-tongue KitKat coating. And right now, their journey from raw bitterness to smooth perfection has only just begun. Then comes the roast, the step Nestlé guards more closely than most nations guard state secrets. Massive rotating drums spin constantly, heating the nibs to temperatures so precise that even a few degrees off could change the taste entirely. For roughly an hour, the nibs dance in the heat, darkening in color and deepening in aroma. This is where bitterness turns into brilliance, where the flavor we call chocolate is born. Once roasted, the nibs are ground into a rich, glossy paste called chocolate liquor, Don't let the name fool you. It's completely alcohol-free, just pure molten cocoa. Inside steel vats, it's mixed with sugar, milk powder, cocoa butter, and a few secret flavoring agents that nobody outside the building is allowed to know. Engineers watch every blend from glass control rooms, tracking data on screens that glow like command centers. But this is only half of chocolate's journey. What turns that paste into something smooth enough to melt on your tongue is a marathon called conching. Imagine heavy metal rollers stirring molten chocolate for 7 continuous hours. The motion crushes every remaining grain of sugar and cocoa until the mixture becomes liquid velvet. Friction warms it naturally, not too hot, not too cold, unlocking hidden notes of caramel and vanilla. During those endless rotations, extra cocoa butter and a whisper of mystery ingredients are added, fine-tuning the taste no competitor has ever been able to copy. When the chocolate finally passes the texture test, it flows into the tempering chambers. Here, heat and cold alternate in perfect rhythm. A temperature ballet that determines whether the chocolate will shine or dull, snap or crumble. Get it right, and you get that flawless break that every KitKat fan knows by sound alone. While all that molten magic happens, another production line wakes up on the opposite side of the factory, the wafer line. If chocolate is the heart of a KitKat, the wafer is its skeleton, impossibly light, perfectly crisp, and geometrically exact. It all starts in towering silos outside the building, filled with a custom flour blend created just for KitKat wafers. Inside, the flour meets sugar, oil, water, and, surprisingly, yeast. Yep, yeast in a candy bar. It's there to breathe life into the batter. The mixture rests for about half an hour while microscopic bubbles form, creating millions of tiny pockets that make the wafers snap so satisfyingly later on. When it's ready, the batter is poured between massive baking plates that look like industrial waffle irons. They close, hiss, and in less than 2 minutes, paper-thin sheets slide out the other end, perfectly even, lightly golden, and etched with a faint grid pattern. Those lines aren't for decoration, they're functional, giving the chocolate filling something to grip so the layers never separate. The baked sheets climb a 30-foot cooling tower, rising slowly through cool air to stabilize their texture. By the time they reach the bottom, they're room temperature and firm enough to handle. That's when the layering begins. Robot arms lift the wafer sheets onto long conveyor belts. Precision nozzles spread a thin layer of creamy chocolate filling across each one. But here's the twist. That filling isn't made from fresh ingredients alone. It's made partly from crushed KitKats that failed inspection earlier in the day. Bars that were too short, too heavy, slightly misshapen. They're ground into dust, melted, and reincorporated into the filling. It's a loop of sweet resurrection, ensuring not a single crumb goes to waste. Layer by layer, the robots stack wafer on chocolate, chocolate on wafer, until a thick, multi-layered sheet emerges. 3 wafers and 2 layers of filling sealed into one perfect structure. Cooling tunnels lock it in place before a phalanx of mechanical knives slice it into familiar rectangles. Each cut is synchronized down to fractions of a millimeter. Overhead cameras watch every move. If a bar breaks unevenly, if a corner chips, if the alignment drifts even slightly, it's rejected instantly. Those rejects will be reborn later, mixed into tomorrow's filling. Meanwhile, deep in another section of the plant, molten chocolate is flowing through silver pipelines like edible lava. It's pumped into molds embossed with that iconic KitKat logo. As the molds fill, robots drop the wafer fingers inside, pressing them just deep enough so that chocolate envelops every edge. The bars pass through vibration tables that shake away air bubbles, then glide towards something unexpected, an X-ray scanner. Each KitKat is scanned just like airport luggage. The system checks for hidden gaps, missing wafers, or trapped pockets of air that could ruin the texture. Any bar that fails is quietly whisked off the belt. Another future rework. The survivors enter the cooling tunnel, a long metallic corridor kept at a constant 50 degrees Fahrenheit. Inside, the chocolate hardens and its glossy surface sets. When the bars finally pop free from their molds, they gleam under factory lights like tiny edible sculptures. From there, the race begins. Thousands of bars stream down high-speed conveyors, their movement hypnotic and endless. At one checkpoint, sensors weigh every bar to the gram. At another, cameras verify the logo's clarity. Each second, more than 100 KitKats either pass or fail. The ones that make it glide forward to the wrapping zone, where chaos turns into choreography. Red foil wrappers zip from spools at blinding speed. Mechanical jaws fold and seal each one so precisely that the logo always lands dead center. 5 million bars can be wrapped in a single day without a single misprint. Next, packaging robots group the bars, twin packs, 4-packs, and giant family sizes, sliding them into boxes with surgical accuracy. Nearby, palletizing machines stack cartons into perfect cubes ready for shipping. Computer algorithms calculate the most efficient arrangement to fit them onto trucks without wasting an inch of space. By the time one shift ends, dozens of trucks are already rolling toward warehouses and grocery stores, each carrying fresh bars born just hours earlier. Somewhere in that mountain of chocolate, a few bars carry crumbs from a previous batch, tiny fragments of KitKats that didn't survive the day before. It's recycled at industrial scale, disguised as deliciousness. What's most striking about seeing it all up close isn't the machinery, it's the precision. Every lever, every sensor, every temperature gauge exists for one reason: to make every single KitKat taste identical. Whether you buy it in Tokyo, Toronto, or London, that texture, that flavor, that perfect snap, it's all the result of a system that doesn't just make chocolate, it engineers emotion, and yet, beneath all the automation, the human touch is still everywhere. Technicians watch from behind glass panels, fingers hovering over controls, eyes on data screens. Quality inspectors taste random samples straight off the line, checking flavor consistency like sommeliers in lab coats. Engineers walk the aisles, listening for sounds out of rhythm, a motor humming slightly off-key, a conveyor whispering faster than it should. They know that in a place like this, perfection is built on sound, smell, and instinct as much as numbers. By the end of the day, the air feels heavy with cocoa and heat. Machines slow to a crawl, lights dim over endless silver belts. Somewhere deep inside a tank, liquid chocolate still swirls quietly, waiting for the next morning, because this factory never truly sleeps, it just takes a breath. The KitKat you unwrap tomorrow will be born from this endless cycle. Beans roasted under the African sun, wafers baked by roaring machines, broken bars reborn as filling, and everything finally sealed under a wrapper that hides a secret no one ever tells you. That perfection is built on imperfection. So the next time you break that bar in half, listen closely. That snap isn't just candy, it's the sound of precision, patience, and a process that turns failure into flavor. If you love seeing how the world's favorite snacks are really made, hit subscribe, leave a like, and tell us in the comments which factory secret you want exposed next. Because this is Process Crate, and we're just getting started.